Welcome back to Engineering Economy. We were discussing this chapter 6, comparing project alternatives with each other and making the best decision, selecting the best alternative. In our previous lectures, we talked about different methods that we can use, and actually we considered different cases depending on the useful lives of the project alternatives and the study period. And the easiest case was when the useful lives of all alternatives were equal to each other and they are equal to the study period. And in this case, we can simply use any one of the methods, the present, annual, or future worth methods, or the rate of return methods. But while using the rate of return methods, we mentioned that we may end up with this inconsistent ranking problem, and because of this, we need to implement the incremental analysis for rate of return. It is important. Then we also considered the case where the useful lives of the project alternatives are different from each other, and at least one of them is different from the study period. In this case, how we can perform the analysis, and we considered different cases depending on whether the useful life is less than the study period or more than the study period, and depending on whether these are cost alternatives or investment alternatives, we talked about different assumptions that we can do. We said that we can either do consider the repeatability assumption, in which the project cash flows repeats itself after the end of the useful life, and we said that we can use the coterminated assumption, so that by adjusting the cash flow of some alternatives, we again bring these project alternatives to the same comparison period. And if the study period is less than the useful life, we said that we can use, for example, the imputed market value to estimate the market value, the salvage value of an item at the end of the useful life, and etc. So these were several discussions that we already did, and in today's lecture, I will solve a comprehensive example for the case where the useful lives of the project alternatives are different than the study period. So let's consider this example for this purpose. And in this one, simply we are going to compare two mutually exclusive alternatives. Remember, mutually exclusive means that when you select one of the alternatives, the other one is automatically excluded. And the MAR is given as 10%, and there are three parts of the question. We will first solve the question assuming the repeatability to be valid. In the second one, we will use the coterminated assumption with a 4-year of study period. And in the last part, we will solve the same example, assuming cotermination and with an 8-year of study period. And the project data is given in this table. There are two project alternatives, and the cash flows of these alternatives are provided in this way. Okay, so in the first alternative, we have an initial investment of 40,000 and annual revenues. And at the end of the 4th year, the useful life of first alternative is 4 years. And at the end of the 4th year, we have a salvage value. And the salvage value here is 24,000. So it is actually 12,000 annual revenue plus 24,000 salvage value. Okay, here this 36,000. In alternative 2, the useful life is 8 years, but look, in alternative 2, the market value at the end of 8th period and the annual revenues are given separately. So they occur at the same time. Don't assume that this is period or year 9. It's still 8, but this is the market value and this is the revenues. Okay, now in the first part, we will compare these two alternatives using the repeatability assumption. And in the repeatability assumption, when we compare alternatives, we will assume that we can repeat the same alternative, same project cash flow until the study period of the two alternatives becomes equal to each other. And this occurs, the two alternatives, the study periods become equal in the least common multiple of their useful lives. And for this one, actually, it is easy because the useful life of the first alternative is 4 years and the second one is 8 years. So it means that if I repeat the first alternative for an additional 4 years, then we already obtained the least common multiple. So what does it mean? It means that for the first alternative, we already have this cash flow, 40,000 investment, then 1, 2, 3, and 4 years of 12,000, plus an additional salvage value of 24,000. So this is alternative 1. And we will repeat the same alternative one more time. And how we repeat it? We will assume that every cash flow occurs. So this is year 1, 2, 3, and 4. And it will repeat itself until the 8th period, okay, 8 year, 24,000. So actually, as you can see, this red one is the first repetition and the blue one is the second repetition, and now we have 8 years of life for alternative 1, and for alternative 2, it's already 8 years. And remember, when we compare two alternatives with each other, the fundamental principle is to compare them in the same time period, same study period. And for this example, with the repeatability assumption, that study period is 8 years. Okay, now we already obtained the cash flows and we will compare these two alternatives. You can use present worth, annual worth, future worth analysis. But if you want to use rate of return analysis, you cannot just find the rate of return for the both alternatives separately and then select the maximum. But instead, you need to do this incremental analysis. It's very important. Okay, so the easiest method here is to use an equivalent worth method analysis, and the easiest one, when you have repeatability assumption, okay, with repeatability, the easiest method will be the annual worth method. Okay, so if there is repeatability assumption, first thing to try is the annual worth method. Why is that so? Because look, we are going to find the annual worth of this cash flow. And how can we find it? It seems to be complicated. But actually, since the cash flow repeats itself, it is satisfactory to consider only one repetition of this, find the annual worth of this one, and it will be equal to the annual worth of the second one. And it means that by just finding the annual worth of the first repetition, we find the annual worth of the whole cash flow. Okay. Therefore, with repeatability assumption, always use annual worth method if the others are not restricted or required. So we find the annual worth of the first alternative. This 40,000, we find its annual worth value. 12,000 is already annual revenues. And this market value, we find its annual worth by a given F formula. And the annual worth is 4,552 for the first alternative. And for the second one, this time we are finding the annual worth. Look here, we used only the first repetition, only 4 years as the number of periods. But the second one, the useful life is 8 years. So I'm using the factor for 8 years and finding the annual worth of this alternative for 8 years, and we find it this one. So these project alternatives are investment projects. and we want to earn revenue. And for this reason, after finding the annual worth, we need to compare these with each other, and we should select the one which maximizes the annual worth. Okay, so therefore alternative 1 is selected. This is part A of the question. In part B of the question, we need to use a coterminated assumption, and it said that we will have a 4-year study period, which means that, remember, the second alternative, useful life of the second alternative was 8 years. But what do? We finish our analysis in 4 years. So what we need to do for this second one? Remember, we have such a cash flow for the second alternative, 50,000 initial investment, and then 40,000 at the end market value, and then 10,000 annual revenues. This was the second alternative, and this is the 4th year, and now we will finish the project, the study, in the 4th year. Okay, if this was the case, we said that we need to use imputed market value, and we need to find the market value of this project alternative at the end of year 4, at the end of the study period. And according to this imputed market value, what do? We first find the capital recovery for each year, and the capital recovery is related to this initial investment and final salvage value or market value. So we find the initial capital recovery. It will be a cost for each year, something like this, capital recovery. Then what we will do is we will find the capital recovery goes for 8 years. After the end of this study period, we will find the present worth of the capital recovery amounts for this part at the end of year 4. And then we will find the present worth of this market value, 40,000, again at the end of year 4. And we will sum up these values to find the market value of this project at the end of year 4, which is the study period. So how do we find the capital recovery? Simply we distribute the initial investment to annual equivalent series, and this final market value to annual equivalent. So this part here, if I multiply it by A given P, 10% and 8, this is the annual worth of the initial investment. Minus, this is the final market value at the end of year 8, and using A given F formula, I find its annual equivalent for 8 years. Okay, and now for this period after the 4th one till to the 8th period, I need to find its present worth at time 4. So for that, I'm going to use this formula, P given A, 10% and 4, because there are 4 periods here, 5, 6, 7, and 8, okay? Therefore, this formula, and on it, I am finding the present worth of this market value at the end of year 7. I find its present worth at the end of year 4, so I am switching it 4 years before. And if I add these two values, this is the market value of the project at the end of year 4. Now what I can do is, I can just ignore the rest of the project, okay? After the 4th year, I can just use the project until the 4th year, but instead of having the market value at the end of year 8, I can simply write here the market value that I found, which is $45,940. Now, this is the second alternative when we finish it at the end of year 4. The first alternative was already in year 4, so I can compare these two with each other now. I'm going to find the annual worth of the second alternative, due to this cash flow. This 50,000, A given P, now 4 periods, 10,000 already annual, and this is the market value at the end of year 4 that we just calculated, and we find its annual equivalent using this factor, and this is the annual worth of alternative 2. What about alternative 1? We already found it in part A. Nothing has changed in part A, in the first alternative. And then we need to compare these two alternatives with each other and select the one which maximizes the annual worth. And as you can see, alternative 1 is the best alternative. So look, part A, part B, and part C are 3 different variations of the same problem. They are not related to each other. Okay, we are not reaching to the same or different conclusions. We may reach to different conclusions in these parts because we are not solving the same problem using alternative approach. We are simply solving different problems in these parts. Okay, so don't be confused. Now, we completed part A and part B. Now we will solve the same example with another assumption in part C. And our assumption here is the study period is 8 years. Okay, so the second alternative was already for 8 years. So there's nothing to do with the second alternative. But the first alternative, the cash flow or the useful life was only for 4 years. And here we are asked to use the coterminated assumption, meaning that the repeatability assumption is not valid anymore. If the repeatability assumption is not valid, you cannot just consider these 4 years. You have to somehow extend it to 8 years. And how? And we said that with coterminated assumption, if the repeatability assumption is not valid, we said that we can reinvest all these positive cash flows after the end of the useful life. We can reinvest them using the MAR. So what we can do, we can use, for example, the future worth analysis, and we need to find the future worth of this investment alternative at the end of year 8, and there are no cash flows from year 4 to year 8. There are no cash flows. But the thing is, assume that we just took this money, our earnings, and placed it to a bank account, and in that bank account we are earning at a rate of MAR. Okay, so what I am going to do for the first alternative is find its future worth, this initial investment at the end of year 8. Okay, I am moving it to year 8. Then this 12,000 only occurs in the first 4 periods. I'm finding its value at the end of year 4, and then shifting it to year 8. I'm going to shift it to year 8 by multiplying with this factor, F given P, 10% and 4. But at the end of year 4, I also have this salvage value of 24,000. So on top of this, I'm adding this 24,000 and then shifting everything to time 8, year 8. Okay, and this is the future worth of the first alternative. And the future worth of the second alternative, we just find its future worth. It already has a useful life of 8 years. Using this equation, and the future worth is this. Okay, then we need to compare these alternatives with each other. Again, we should select the one which maximizes the revenues, and in this case, as you can see, alternative 2 maximizes my revenues. So it will be the one to be selected when we use the coterminated assumption with a study period of 8 years. Remember, if the repeatability assumption was valid with the 8 years of study period, we selected the first alternative. But if it is not valid, if we need to use the coterminated assumption, then we use alternative 2. So these alternatives, repeatability assumption and coterminated assumption, which alternative is valid, should be identified carefully to make the correct decision and the best decision. So this is the end of this example. In the following, I'm going to summarize what we learned in this chapter on comparing alternatives with each other. So this chapter was about comparing more than one project alternatives with each other. We first learned that there are either investment alternatives or cost alternatives. In investment alternatives, each of the alternative usually has an initial investment, initial spending, and later they produce positive cash flows. And for investment alternatives, if let's say there are alternative A's and alternative B, you don't need to select one of them. You can also select the do-nothing alternative. Okay, do-nothing alternative means that you are not selecting A, you are not selecting B, you are simply doing nothing. You are using your MAR to earn revenue, maybe with your money. Okay, or if one of these alternatives is better, provides more than MAR, then you can select one of the alternatives. But the thing is, these alternatives are mutually exclusive. It means that you have to select only one of them. The others will be excluded. And if the alternatives are cost alternatives, it means that all cash flows are negative. Only the positive cash flow can be the salvage value, it appears sometime, which is at the end of the project lifetime. And these cost alternatives are usually must-do alternatives. There is no do-nothing alternative here. Usually they are service projects, they are public projects. You need to construct a bridge or something, for example. Okay, therefore, you have to select one of the alternatives, and here we select the alternative with the minimum spendings, minimum cost, and etc., using, again, these techniques that we learned. Then we learned how we compare alternatives when the lives of the alternatives are equal to the study period. And for this case, the simplest approach is to use one of the equivalent word methods: present word, annual word, future word, and etc. Okay, one of these methods. And here, if you use these equivalent word methods, the decision rule is to select the alternative with the highest equivalent word. Okay? And if comparing cost alternatives, if we are comparing cost alternatives, we will select the project which has ends up with the least equivalent word. Okay? If you want to use rate of return analysis for the case that the useful lives of the alternatives equal to the study period, then you need to use incremental analysis. And for this incremental analysis, we start by selecting a base alternative. The base alternative is the one with the smallest investment cost and satisfies the needs, which means that it provides a rate of return more than MAR. Okay, the base should be an acceptable project. And in this incremental analysis, the decision rule is this. We find the IRR, the rate of return, internal rate of return of the difference, the incremental project. And if this is greater than or equal to the MAR, we eliminate the base, and the new project becomes our base. Otherwise, if IRR of the incremental cash flow is less than MAR, then we keep the previous base and move to the next alternative in sequence. Okay, so this is how we use the incremental analysis. Don't ever do this. Don't ever select the alternative which provides the highest rate of return. Otherwise, you may fall into this wrong situation of inconsistent ranking. The other situation is when the useful lives of the alternatives are different, and they are different from the study period. So for this one, if the repeatability assumption is valid, then the simplest approach is to use the annual worth, as I explained in the previous example. So find the annual worth of each of the alternatives in their own life. You don't need to repeat how many times you don't need to think how many times you are repeating. Just consider each alternative within their own life and find the annual worth, and select the alternative which maximizes the annual worth. Okay, this is the simplest when you use repeatability assumption. Of course, you can use present worth or future worth here, but in that case, you cannot consider only their own life. You need to find the present worth or future worth at the beginning of the project or at the end of the study period, which means that you need to deal with a complex cash flow here. So annual worth is easier. And if you want to use rate of return when repeatability assumption is valid, again, you need to use the incremental analysis, and you need to calculate the rate of return for the difference incremental cash flow. And actually, you can find this incremental cash flow, the rate of return of this incremental cash flow, using this way. You can find the annual worth of the base, and you can find the annual worth of the next alternative with the smallest investment cost. And then you try to satisfy this equality by finding the interest rate. Which interest rate satisfies this equality? And when you find it, you find the rate of return of the incremental cash flow. If it is greater than or equal to MAR, you eliminate the base and move to the next comparison. Otherwise, you keep the previous base and move to the next comparison. This is the repeatability assumption when the useful lives are different. When useful lives are different, and if the repeatability assumption is not valid, you can use the coterminated assumption. Okay, and in the coterminated assumption, the simplest approach here is to use is to bring all cash flows to time n. Okay, let's say longest lived alternative. But to do this, in repeatability assumption, we were repeating the same cash flow. But in coterminated assumption, we don't repeat the cash flow. Like in the part C of the previous example, for the first alternative, its useful life was 4 years. But in order to find its future worth at time 8, we assume that from time 4 to time 8, there are no cash flows. Okay. So this is one alternative. Another alternative in this coterminated case may be to select the shortest life project alternative, and for the other alternative which has a longer life, find its imputed market value at the end of the study period and compare the alternatives with each other. You can also use the rate of return approach together with coterminated assumption, but still, when you are using rate of return, you need to perform incremental analysis. Simply, you have two cash flows, alternative 1 and alternative 2. Either you use the first approach here and select the longest one, but does not repeat the cash flow, or use the imputed market value for the longest one and select the study period as the shortest one. Now you have two alternatives with equal study periods and their cash flows, and for this perform incremental analysis as we learned it. Okay, so this is what we learned in this chapter on how to compare project alternatives with each other.